Okay, so in this lecture, I'm going to talk about interfaces and testability. I'm going to show you how interfaces improve the testability of your application. This lecture is heavily focused on coding, and we are not going to have any slides. So let's jump into Visual Studio and see how interfaces help improve the testability of applications. Okay, in this example, we're going to see a very basic hypothetical order processor. In a real-world application, this is going to be far more complex. But I have removed all that complexity here because we just want to focus on testability. So let's see what's happening here. We have an order processor here. We'll take a look at that in a few seconds. We also have an order object. And finally, we call the process method of the order processor passing the order object. Let's take a look at the implementation of this method. To get there, simply press Shift, Control, Alt, and B. There we go. So here's our order processor class. It has a field that is read-only and private. It's of type shipping calculator. So we use this calculator to calculate the shipping cost, as you will see shortly. In the constructor here, we instantiate this object. And here's our order processing method. So in the process method, we get the order object. First, you see an example of defensive programming. So first, I'm validating if the order is already shipped. If it's shipped, I don't want to ship it again. So a bit of defensive programming is good to have in your methods to make sure that you don't take the state of system to something that is unexpected. But on the contrary, if you're going to do too much defensive programming, your code is going to be bloated with too much validation. So at this point, I think it's just enough to see if order is shipped, then we throw an exception of type invalid operation exception, which states this order is already processed. Now, if the order is not shipped before, we simply create an object of type shipment and assign it to the shipment property. The shipment class has two properties, cost and shipping date. To calculate the cost, we use our shipping calculator. So we pass the order, and that shipping calculator knows how much the shipping cost should be for that order. For shipping date, I have hard-coded a rule here that states shipping will be done the day after the order is submitted. Again, this is a hypothetical scenario and it's most likely not the case in real-world applications. Now let's take a look at the calculate shipping method here. So simply put your cursor here, press Shift, Control, Alt, and B. Okay, in this method we have a simple rule. So if the total price of the order is less than $30, the shipping cost is going to be 10% of the total price of the order. Otherwise, if the order is $30 or more, we're gonna give a free shipping to our customers. So pretty basic. Now let's get back to our order processor. Okay, let's say we want to write a unit test for this process method here. If you have never done unit testing before, that's perfectly fine. I'm going to introduce you to the concept of unit testing briefly. Note that unit testing is a comprehensive topic and is way beyond the scope of this course, and I definitely plan to create a comprehensive course explaining the best practices of automated testing for C# applications. But at the time of recording this, it's not ready. In case you want to be notified about that course when it's ready, follow me on Twitter or Facebook or my YouTube channel. The details are in the introduction section of this course. Okay, let's move on and see what is unit testing all about. Unit testing is part of automated testing practice, which means we write code to test our code. So instead of we manually test our software every time using clicks and typing, we write some automated tests to achieve that. Now let's see how this happens in practice. So in Solution Explorer here, I'm going to right click and go to Add, New Project. In the left section under Visual C#, you see Test. So we select Unit Test Project, and I'm going to name it after my project.tests. So in this case, my project is called Testability, which is the name of this lecture. I'm going to name my unit testing project testability.tests, or better, unit tests. In your project, whatever is the name of your project, just put that here instead of testability. Let's press enter. Okay, here we have a unit testing project. By default, Visual Studio creates a test class for you here, which is called UnitTest1. Note that each test class has an attribute called test class, and it can have a bunch of methods like the one you see here, which are decorated with test method attribute. In C#, attributes represent metadata about your classes and their members. They don't have any logic, they're just markers. Then another application or another assembly can read this metadata and do something about it. For example, later you're going to see that we're going to use Microsoft Test Runner, and that test runner is going to look at all classes that have a test class attribute. And then it's going to run the methods that have a test method attribute like here. Okay, before we write our test, let's take a look at our order processor and see what kind of test cases we need to write. So back here. Okay, take a look at this process method here. Here we have two execution paths. One is if the order is shipped, we're going to throw an exception. The other one is if order is not shipped, we're going to change the state of the order by setting its shipment property to a new shipment object based on some values here. Now there is a problem here. The problem is that when we unit test a class, we need to isolate it, which means we need to assume that every other class in the application is doing its job properly, so we can write tests around this class. And that's why we call this practice unit testing. We are focusing on a single unit of functionality without dependency on any other parts. Now in this order processor class, we have tight coupling to shipping calculator. Look, here we have a shipping calculator which is instantiated in the constructor of order processor. So because of this tight coupling, we cannot isolate this class. So when we write tests for this piece of code here, this dependency to shipping calculator is going to be a problem. How do we solve that? Using an interface. So let's go to our shipping calculator class. This shipping calculator has one method called calculate shipping. We need to create an interface that has this functionality and then have the shipping calculator implement that. What does it mean? Remember the analogy I used for the chef? I said a restaurant needs a chef who has certain capabilities. Whether it's John or Mary or Steve, it doesn't really matter, as long as that person can fulfill some needs based on some standards. It's exactly the same scenario here. By using an interface, we're defining that role of calculating shipping. Now, which class is going to fulfill that role? It's a separate issue. In this case, this class is going to be fulfilling that role. It's like John being a chef. Now, let's create an interface here. So, similar to a class, public interface. We give it a name, iShipping calculator. Note that the name of the interface is prefixed with capital I, and that's a convention in .NET Framework. Now here we need a method called float calculate shipping, which takes an order object. Note that this method does not have a body like this. If you do that, you see this red underline here, highlighting an error. So let's undo that. Also, there is no access modifier here, so we cannot say public, private, whatever. See, it's not going to work. This interface simply defines the capability that a class should provide. Now, we need to have this shipping calculator class implement that iShipping calculator interface. How? We go here and type iShipping calculator. It looks a little bit similar to inheritance, right? But this is not inheritance. Because with inheritance, we write code once and then we reuse it. We don't have to type it again. But in this case, you see, we have this method declaration here, but we had to manually type all this code here. So this is not inheritance. We read this as shipping calculator implements iShipping calculator. Okay, now that we have this interface, let's go back to our order processor. Instead of being dependent on this concrete class, which is like John as a chef, we want to be dependent on an interface, like the role of the chef in a restaurant. So what I'm going to do is simply put this I here, and now we have an interface. And instead of creating a new object of shipping calculator here, we need to initialize this field using the constructor. Why? Because here, we're still dependent on that concrete shipping calculator class. So what we need to do is we go here, pass a parameter of shipping calculator type, shipping calculator, and initialize our shipping calculator field using this argument. Look, now there is no reference to the shipping calculator concrete class. We're just referencing an interface. And this is an example of loose coupling. So if we go back to this shipping calculator class and we change its code, let's say we add a few new methods or change this logic here, it's not going to have any impact on our order processor class. Order processor doesn't know about shipping calculator. It just knows there is a class that can fulfill that need. Now, if we build our application at this stage, it's going to fail. Let's take a look. Control-Shift-B to build. Build failed. Let's double-click this error. Look, in the main method here, when instantiating an order processor object, we need to pass that shipping calculator. Look, it needs an instance of shipping calculator. So here we need to specify that concrete class, which is shipping calculator. Now here you might be thinking, isn't that dependency to shipping calculator? Yes, it is, but it's in the main method here, which is outside that class. The main method here is like the matchmaker. It knows different concrete types and ties them together. But none of these concrete types, like the order processor, knows about the existence of other concrete types. So in this case, it's perfectly fine to instantiate this shipping calculator object here. Let's build again. Okay, the project is working. Now let's get back to our order processor and review our test cases. There you go. So the first test we need to write is if order is shipped, this method is going to throw an exception. Let's see how we write a test for that. So I'm going to open that unit test1 file here, which is inserted into the test project by default. I'm going to rename it. You can press Ctrl R and then R again or F2. Because we are writing tests for order processor, the name of this class should be order processor tests. Now the name of this method should be based on a convention like this. We have the method name, underline, the condition that we're testing, underline, expectation. So here's the pattern. Let's see how it works. So in this case, the name of method we're testing is process. The condition is order is already shipped. And the expectation is throws an exception. So note that the method name is very descriptive. It can act as a documentation. Okay, now let's see how we can write a test for this class. So the class we're testing is order processor. Let's create an object of that type. So var order processor equals new order processor. Now, because I'm using ReSharper, I can easily press Alt and Enter here, and the first item is reference testability and use testability.orderProcessor. The reason for that is because here we are in a separate project, in our unit test project. We need to reference that project so we can use the classes defined there. So I'm just going to go ahead with ReSharper's refactoring. If you don't have ReSharper, you need to go here, right-click References, go to Add Reference, and then under Solution, under Projects, tick that testability. Okay, now here we have the order processor object, but we have to specify its dependency, which is shipping calculator. Now, what do we need to pass here? We need to pass a fake object that is always working. We are not going to pass that original shipping calculator because we are trying to isolate that order processor, right? So let me create a fake shipping calculator. So public class fake shipping calculator. This class should implement shipping calculator interface. Note this red underline here. That is here because we have not implemented this interface, which means we have not defined the methods that are declared in that interface. So for that to happen, you need to press Alt and Enter, and Enter. This shortcut always works whether you have ReSharper or not. Now you see we have this method called calculate shipping based on the declaration in that interface. And note that this method is automatically declared as public. If I change it to private, compiler is going to complain. Because methods declared in an interface should be public. So basically, as you see, an interface defines the public interface or the public functionality or the public service that a class provides. All right, in this method, I'm just going to hard code a simple number because we're not going to have a logic. We're assuming this fake class is doing its job properly, and our focus is on testing the order processor. We're trying to isolate it, right? So let's pass an instance of this fake shipping calculator here. And now I want to create an order that is already shipped. So let's create an order. How do we know if the order is already shipped? Let's go to the order class. Look, here I defined a property called isShipped that checks if the shipment object is not null. So if the shipment object is not null, this property is going to return true. So back to our test. What I'm going to do is simply, I use the object initialization syntax here, and at the same time I'm initializing the order, I also initialize its shipment property. Just set it to an empty object. This way, its ship property is going to return true. Now let's call the process method. So order processor.process and pass the order object. So here, what we need to assert is that an exception is thrown. With the default testing framework that comes with Visual Studio, you can achieve that using an attribute here. That's called expected exception. Here we need to specify the type of exception. So type of invalid operation exception. Note that here we are using Microsoft testing framework. If you're using other testing frameworks like NUnit or XUnit or whatever, the implementation could be slightly different, but the concept is exactly the same. We have to isolate a class using an interface. We need to arrange some preconditions. We need to act on a method, and then finally we need to do assertions. Okay, now let's run this test and see what happens. If you have ReSharper, the shortcut is Ctrl-T and R. Without ReSharper, you press Ctrl-R and then A. If you forget the shortcut, simply go to Test menu. This is Visual Studio's testing framework. Under Run, you see you can run all tests using that shortcut. With ReSharper, we go to Unit Tests and Ctrl-T and R as specified here. So let's run this. Note that we got a green tick here. Now let me show you something. If we go back, let me close this. If we go back to order processor and comment out these two lines here, and then go back to the test class and try to run this test again, note that this time the test failed and we got this red icon here. So the description here explains that this method did not throw an exception, which was expected from the process method. So let's close this. Back to our order processor class. Let's bring this back in. Okay, now let's write the second test case. So if the order is not shipped, we want to make sure that the shipment property is initialized properly. So we go back to our test class. Following the same pattern here, we're going to write another test method. Public void. The method we're testing is process. The condition is order is not shipped. What should happen? Should set the shipment property of the order. We decorate this method with test method attribute. Now we need to create an order processor object. So we can simply go here and copy paste this code here. This time I'm gonna create a new order object, but I'm not gonna initialize the shipment property. So is shipped is going to be false. And now if we call this order processor.process method, passing the order object, we need to assert that the order.shipment is initialized properly. To do that, we use the assert class that comes as part of the test framework. This class provides a bunch of useful methods for various kinds of assertions. First, we want to make sure that is shipped is set to true. So is true, and we pass order.isShipped as an argument. We need a couple more assertions here. Let me scroll down so you can see this better. Okay, let's get back to our order processor. Look, apart from this shipment property being initialized, we also need to make sure that the cost is set properly and shipping date is set to tomorrow. Now in this case, because we isolated our order processor and passed a fake shipping calculator here, if you remember, that method always returns 1. So we need to assert that the cost is set to 1. And for shipping date, we can assert that it's set to tomorrow. So let's get back to the test method. Okay, I'm going to write another assertion here. So assert dot. This time I'm going to use the requal method. The first argument to this method is the value that we expect. So the cost should be 1. The second argument to this method should be the actual value, which is going to be order.shipment.cost. And we write a similar assertion around the date to make sure that the date is calculated properly. Assert.requal. The date should be tomorrow. So datetime.today.addDay 1. And the actual value, which is the second argument to the requal method, is order.shipment.shippingDate. Let's run this test. So the test passed. Okay, before we finish, let's recap. So back to our order processor. Previously, this class had a field of type shipping calculator, and because of that, it was tightly coupled to that implementation. We reduced this coupling by introducing an interface, iShippingCalculator. With an interface, this class is no longer dependent on a concrete class, which means we can isolate it during unit testing. So the takeaway from this lecture is, when you're trying to unit test your classes, if that class has other dependencies in terms of concrete classes, you can use an interface to reduce that coupling. Before we finish this lecture, let me show you a quick way to extract an interface from an existing class. So let's get back to our shipping calculator. Imagine we didn't have this interface before. So I'm going to get rid of it. So here's the original shipping calculator class. If you have ReSharper, you can press Ctrl, Shift, and R to activate refactoring options. But unfortunately, that shortcut is not working for me here because I'm using a Mac keyboard. So the alternative way is right-click the type here, go to Refactor. This is part of Visual Studio refactoring tools, and you will always have this whether you have ReSharper or not. Then go to Extract and extract the interface. In this dialog box, you see the name of the interface automatically populated for you, iShippingCalculator, and here you can tick all the members of this class you would like to extract in the interface. In this case, we have only one method, and that's why you see only one item here. So let's click Next. There you go, we got an interface here, and that is automatically implemented by Shipping Calculator class. So this way you don't have to manually go and type it all. I just did it before because I wanted to show you how to create an interface from scratch. In the next lecture, we'll see another use case of interfaces, and that is for increasing extensibility of an application. I hope you enjoyed this lecture, and thank you for watching.